Welcome friends. So um, now I'm going to introduce a new class and I will use that class to introduce many more new topics in future. So it is something similar to what we did here, where we created a vector of person pointers, and the vector was of the base pointers so that we can point to individual objects of derived classes. Instead of using a vector, I'm going to make a dynamic array, just because sometimes it's good to practice with that. Vectors are easy, and vectors have some inbuilt functionalities which make things easier for us, so it's definitely good to use them. But we also want to learn programming, we want to do more things, so we will just use our dynamic arrays. So I'm going to add a new class, and this new class I'm going to call as a course. Now you know that many students can enroll in a course, and then also there is at least one faculty who is teaching a course. So there is a relationship between these people, which means the faculty and also students. I'm also this may not be the most appropriate or best example, or there may be a better ways to do these things, but I am just going to create one array that is going to contain the list of both the faculty and students, just because we want to learn polymorphism and play with it. So I'm going to create an array, and for that, first of all, I will include person.h, and then I'm going to create a person pointer, and I'll call it array. So we know that when we want to create a dynamic array, we want to use the we create a pointer, and when we create the array we use that pointer. We also need size of the array, so we will have the size here. Now first of all, in the course, the constructor, the default constructor, two things we need to do is we need to initialize array, and I'll use the initialization list here. So array is null, because we want to make sure that the pointer is pointing to null. We could also use 0 here, because null is just a representation of 0, so we could use null here. And then we also want to initialize size to 0, because our array is empty, there is nothing in here. And just for fun, I'm going to include this debug output saying if debug course class default constructor called. That's just for our learning purpose, we usually don't do that always in production code. Okay, so now let's add another constructor, and you know the constructor has the same name as the class, doesn't return anything, and we will pass integer size to that so that we can create a dynamic array of that particular size. So we still set array value to null. We are not creating, we will create the dynamic array. Actually we will create the dynamic array, so we will set the size to size. I need to fix this, there has to be underscore here. Okay, so we initialize size to size, and what we want to do is we want to initialize array to new person. So you probably remember this syntax for creating new array, a dynamic array of size. So this is going to create a new array of objects. Now again, this is not ideal situation, as I said, because this array is of actual objects, not of pointers. We could create an array of pointers, but that's a little bit more complicated, and I don't want to put too many complicated things together, so therefore I'm just keeping it simple. We have an array of objects, so we may have objects of actual person objects, or they could be they could be array of persons, or they could be array of students, faculty or So we also now so as I said, we could have an array of person objects. I realized that actually we cannot, when we compile this we will get an error saying that invalid new expression of abstract class type person. And the reason is because we made the person class abstract. If you remember, we created a pure virtual function. That means we cannot have the objects of class person. And so when we compile this code, of course it says that, well, you are trying to create, or actually here we are trying to create objects of class person in the array. That's not allowed because we cannot have objects of class person. And as I said, that's anyways not ideal. The best would be to actually have array of pointers. So I will do that. I'll create an array of pointers. So it's a pointer to a pointer of, and then when we actually create the object, it's not really complicated. Here we just say this array is of person pointers. Now we are not creating person objects, and so we are fine, and this code will compile without any problem. Now what we want to do is, just to make sure that we are on the right track, we are going to in main include course.h, and then we will create a course object, course well, let's call it CS3933, and well, let's call it with 7 students, okay, or 7 objects. So I compile the code, everything looks good so far. When I run the code, we don't get any output because I have not added the debug output here. So I'm going to add the output. I'll call it one arg constructor called. And you remember, when we are creating the array, we are creating an array of size 7 here in course.cpp. We are setting the size to 7, and we are creating an array of that can hold 7 pointers to 7 objects, but we are not actually creating the objects yet. So when we run this code, we will see the output saying course class 1 argument constructor called, but we don't see the objects getting created. So let's create a couple of objects and add them to course. Now to be able to add course objects to courses, there are 2 ways. One is we can make the array public, so we can set the value, but that's not a good idea because that's actually violating the principle of encapsulation. So therefore we will create a method add person. We'll just call it add, because it could be a student or a faculty, and although it is of a class person, the base pointer will be class person. Well, let's make it more meaningful, so we'll call it add person, and we'll pass a person pointer to this function. Okay, so now let's add the definition. And the only thing what we are doing is, we know that size contains some size, the total size of the array. So now we discover that we need some way to also know that how many actual objects are there in the array. So size is the total size, but we really don't know how many are actually how many objects are actually there. So we have to add another variable here, and we will call it count. Okay, and this is actually what we do in iterative or agile methods. We work and then we realize we need to do something. Count will be 0 here because the count, we don't have any objects yet. Okay, so now what we do is, once we know we are creating a person object, we want to check if count is less than size. That means we have not actually, we don't have actually as many people, the array is not full. So then we add the element or person to that particular location in the array. So array count equals person. So we are assigning the pointer array is of pointer objects, and we are assigning that pointer at this particular location, that's count, and then we increment count by 1. So we'll say plus plus count, although we could do this in one expression by doing count plus plus here, but I'm just keeping it separate to keep it simple. Now when we have one person, the count will be 1 and size will be 5. When we have 5 people, count will be 5 and size is also 5. So we have to make so this is the right comparison. When count is 4, that means we have room for one more person, and when count is 5, this condition will be false. That would mean that the array is full. So we could also output something which is nice, and for now we will put that in a debug, and I'll show you. This is nice. Else, now usually we would not like to output things, but if we are in debug mode we would like to output this. So I'm putting this else as well as hash if def. So if the array is full and we are in debug mode, then we are outputting that the array is full. Otherwise, if it's not in debug mode, then it will just be silent, it will not add anything. So that's just one thing I wanted you to see. Also we could put the whole else thing inside hash if def debug. That's also okay. Either ways this will work. So when I compile count, I need underscore everywhere, and size is also needs underscore. Okay, we'll get used to that. Okay, so now we have a function to add a person. Actually, let's do this. We will also debug and add information here. Person added at index . Count -1. Okay, we are doing count -1 because, or we can just keep it simple. Okay, so we are producing an output that the person was added at index count, and then after that we are incrementing count. So let's test our code now. So we create a student object, actually a pointer, because we need the pointer value to stay, or the object to be dynamic. So it's a new student object, and let's use this second function here. So ID is 2, name is Bob, and GPA is 3.1, and when name the major is, let's say, ME. Okay, and now we want to add this student to our course. So cs3933.add_person, and because you have seen this before probably, that although the add person method takes a person pointer, we can pass a student pointer because that will be downcasted or upcasted to the base class, and we can add a student object appropriately to the array. Okay, let's compile this code. It builds, and let me run this code. So now we can see here course class 1 argument constructor called, then we created a student object, and then we added that person at index 0. So looks good so far. Let's add another student, and now I'm going to reuse this student pointer, because once the pointer is added, or the object is added to the array, we have a handle to that student object, So when we want to delete it or we want to process, we can do that. So we don't need this temporary pointer anymore. We have the pointer in the array. So let me add this with us 3, call it Tim, 3.5, maybe CPE, and then we will call again add person. Okay, so now we have another person, student, and then person added at index 1. So looks like it's working so far good. And in the course class we would do something. We would add a method to print. So there is always, it's nice to have a method which prints information, and this is a const method which is actually adding or not changing the object but just adding. And I'll write a comment because it's always nice to add comment. Add person to the array, print information, print all information in the array. Okay, so let me add the definition here, and this is, so now the print function, I'm going to simple thing is we just say for int I equals 0, I is less than count. So our count is actually keeping track of how many elements we actually have in the array, and plus I, and then we want to make sure so if we have 0 elements, the loop will not run even once. If there is 1 element, the loop will run once. So looks good. And then we will see out. Now actually we don't need see out, we need array. You know that we have a print method inside each class. So actually array is a pointer, or array is an array of pointers, and you can see when I have arrow, then we can see that it's showing all the attributes or methods members available in the person class, because although the array is actually pointing to a student object, but the array itself is of person pointers, so therefore it doesn't know that we cannot use the other methods. We can only use the methods of the person class. And because print is a virtual function, the actual function that will be called will be the students function, so students print. And now we will do cs3933 dot print. Okay, so let's compile this code. It builds. Running the code, we can see here we have person ID 2, name Bob, student GPA this. So looks like everything is working fine so far. We could also add a faculty here. So let's add a faculty pointer, faculty, new faculty object, and then we have ID, name, department, and salary. So let's add ID 123, name, I'll use my own name, and department I'll say ECE department, and salary I'll just put some number here. Okay, so and then we will add this new faculty object to the same course, because just to have them together. So when I compile the code, it works fine. So we are adding a faculty object here, and it's added at index 2, and you can see when we print, all the information is printed. The first two print statements call the print of the student class, and the last one calls the print of the faculty class. We have seen this with vectors, now this is with arrays. So I hope you understood the context and you understood what we are doing right now. So I'll pause this video and continue in the next one. Thank you.